Let's take a look at sample problem 6C from page 212 in the text. It talks about a 2,250 kilogram car, and it's moving or slowed uniformly from 20 meters per second, so that's our initial, to 5 meters per second, both to the west. And it asks, or this happens in 4 seconds, and it asks for what is the force acting on it to slow that vehicle, and how long does it take, or what is the distance that it takes to slow this vehicle down. So I'm going to use the impulse momentum, okay, and this, my change in x, we learned from chapter 2, and all it is, initial velocity plus final velocity divided by 2, average velocity times time. So that'll give me my change in x. So let's take a look at my force. So I'm going to have 2,250 kilograms times my final velocity, 5 meters per second, minus 2,250 kilograms times 20 meters per second. And all over my change in time. In this case, my change in time was 4 seconds. All right, so when I do my multiplication, now my 2,250 times 5 is 11,250 minus, now when I do the second part, this part, 2,250 times 20, in this case what I'm going to end up getting is 45,000. Still over my 4 seconds. All right, so when I solve this now, when I do my 11,250 minus my 45,000, I end up with negative 33,750 all over 4. All right, and my units on these are going to be kilogram meter per second and seconds. So essentially what I'm going to get is kilograms times meters over seconds squared. So kilograms times meters per second squared is mass times acceleration. Mass times acceleration is a Newton. So my force, when I end up doing my division here, negative 8.45 times 10 to the third newtons west. Okay. And again, the negative, it helps us or shows us direction. So this would end up being 8.45 times 10 to the third newtons east. So that gives us the force needed. This is the force needed on this problem. Now we need to go back and take a look at, again, our distance. Okay. So we're going to use this, change in x equals 1/2 initial plus final over change in time. And all we're going to do is substitute our values in here. All right, so my change in x is 1/2 initial plus final. So 20 meters per second plus 5 meters per second times our change in time, in this case was 4 seconds. All right, so when I do this, change in x equals, when I do this math, I get 50 meters to the west. So those are our two answers, 50 meters to the west, 8.45 times 10 to the third newtons to the east. Now, it moved to the west, but my force was to the east. So they're in opposite directions, which shows that this vehicle was slowing down.